So this is what you were working on yesterday. So hopefully things started clicking and going well. Let's get ready to check. So the first thing is we are asked for holes, vertical asymptotes, and horizontal asymptotes. So I recommend starting here because you can do this before you factor. So we're looking for degrees for horizontal asymptote. Well, in the first one, you have a degree of 1 on top and a degree of 2 on the bottom. So this is the case where the bottom is bigger than the top, and in that case, the horizontal asymptote is y equals 0. Now we need to go back and find our vertical and determine if it's a hole or an asymptote. So I look to see what I can factor. The numerator has a 2x. There's nothing to factor there. Denominator, there's a couple things we can do. First, we can look for what they have in common, and they're both divisible by 2 and 4, so we're going to take a 2 out, but they both also have an x, so we're also going to take out an x from each. So if I take a 2x from 2x squared, well, 2 divided by 2 is just 1, so that's gone. X squared, take away an x, we're left with 1x. Do the same thing with the 4x. 4 divided by 2, that's 2. I have an x, and I'm taking it away, so I'm just left with x plus 2. So this is our factored form. So now we're going to set both parts of the denominator equal to 0. So I have 2x equals 0, and x plus 2 equals 0. Well, to solve 2x equals 0, we're going to divide by 2. 0 divided by 2 is, of course, 0. And if I have x plus 2 equals 0, that means x would equal negative 2. Well, now we check to see, would anything cancel? Because if it cancels, that's a hole. Well, there's a 2x on top and a 2x on the bottom, so those would cancel, which means x equals 0 is a hole. The x plus 2 would not cancel, so x equals negative 2 is your vertical asymptote. Number 2, same thing. Let's start with our horizontal. So the degree on top is a 2. The degree on the bottom is a 1. Whenever the degree is bigger on top, there is no horizontal asymptote. So I'm going to put none here. Now we look to see what I can factor. 25x squared minus 4, that's the difference of squares, because 25 and 4 are perfect, and there's a minus sign. So it's going to be 5x plus 4 and 5x minus 4. Sorry, not 4. 2. Forgot to take the square root of it. Remember, when it's difference of squares, one has an addition sign, one has a minus when you factor it. The denominator, 5x plus 2, can't be factored. So now that it's in factored form, remember we only set the denominator equal to 0. I'm going to do that at the bottom here. Now this one we actually have to do a little bit of work to solve for x. So we're going to subtract 2. So I have 5x equals negative 2. To get x by itself, we then need to divide by 5. So x equals negative 2/5. Well, I've got to check if that's a hole or vertical asymptote. So I go back up here. Would something cancel? The answer to that is yes. These would cancel out. So x equals negative 2/5 is a hole, which means there are no vertical asymptotes either. Here are the answers from yesterday. They are labeled VAs or holes for 1 through 9, and it shows you why it's a hole where it would cancel. So scroll through these, check your answers. You might have checked them yesterday as well, and then scroll this up when you are ready to check 10, 11, or unpause this when you're ready to check the last problems. All right. At this point, you should be ready to check 10, 11, 12, and 13. It explains where the degree is the bigger or the same, which means how you get your horizontal asymptote. None of these had a bigger degree on top, so none of them were no asymptotes. If you pay attention to number 13, this one just had a 2 on top without a variable, which means we don't have a degree for it. The degree would be 0. Yes, there's an exponent for 2 of 1, but degrees only occur with variables. Right, when you're done checking, you need to pass out the next set of notes, 5-2. We'll be using those notes for today and tomorrow. Today we're going to continue talking about rational expressions. We started those the other day. Again, a rational expression is the quotient of two polynomials. And just like we did in the previous section, we're going to set each factor of the denominator equal to 0. These are holes and asymptotes on a graph. They don't change. However, when we're just talking about simplifying rational expressions and we're not talking about their graphs, they're referred to as the restrictions. So we learned what they represent on a graph. Today with simplifying, they just aren't allowed to exist. And then we're going to cancel between the top and bottom if possible. So to be honest, this is pretty much what we just did yesterday, but we're no longer calling them holes or asymptotes because we're not talking about what they look like on a graph. We're just talking about simplifying. So in our first one, x squared plus 7x plus 10 over x squared minus 3x minus 10. Just like yesterday, our first step is to factor. So for the top one, we've got 1 times 10, which is 10, and the factors have to add up to 7. Well, those factors would be 5 times 2. So I have x plus 5 and x plus 2 on top. We then move to the denominator. This time we've got 1 times negative 10, which is negative 10, and it has to add up to negative 3. So to multiply to negative 10 and add up to negative 3 would be negative 5 times 2. So my parentheses will be x minus 5, x plus 2. So now that we factored, just like we did yesterday, we're going to find what would make our denominator equal to 0. So we're going to set each factor equal to 0 and solve for x. So I go x minus 5 equals 0, x plus 2 equals 0. So that means x equals 5 and x equals negative 2. Now, because these are restrictions, we say these are what they cannot equal. Because think about it, if it's a hole or an asymptote, they're the points that they don't ever reach. So these are values that are not allowed to be put into this fraction. Well, next, I then look to see if I can cancel. So I'm looking for parentheses or things that are like on top and bottom. Well, I can cancel out the x plus 2's. So the simplified answer, because not only do we state restrictions, we also simplify it, would be x plus 5 over x minus 5. This is why you need to state your restrictions before you cancel, because notice the x plus 2 is no longer in our problem, but because it was in the original part, we still have to state that restriction to it. Also keep in mind, because these are a quantity, I cannot just cross out the x's or the 5's. Once we've factored, the parentheses have to be identical. You cannot factor, or you cannot cancel part of an addition or a minus expression. Looking at our next example here, notice this time there's no plus or minuses, so there's nothing to factor. So we're going to start by looking at what the denominator can't be, because these are, again, restrictions. And then we're going to look at how we could simplify this fraction. Well, let's talk about this. I have a product here. So if I am multiplying what number could I multiply negative 6 by that would turn it into 0? Well, the answer to that is 0. Times 0 is the only way to get a number to 0 when multiplying, which means our x cannot equal 0. But what if x wasn't 0? How would we get it to multiply? Well, that would mean that your y could not equal 0. So when you're multiplying, really and truly, your variables just can't equal 0 because multiplying by 0 is the only way to turn a problem into 0. So now we just start simplifying like this was a regular fraction. So I look at 24 divided by negative 6, which is negative 4. And since the 24 was on top, that means the negative 4 goes on top. I have 3 x's and x cubed on top and 2 on the bottom, which means I have more on top and I've got 1 more. I have 2 y's on top and 3 on the bottom, which means I've got 1 more on the bottom. So here is the answer along with those restrictions. Go ahead and try the next you try, and then unpause this when you're ready to check. All right, here we go. So the first thing we're going to do is factor. So the top part, you should have factored to x plus 4 and x minus 2. The denominator should have been factored to x minus 3 and x minus 2. Be careful on this one. There's several factors of 6 that can add up to a 5, but it has to multiply to a positive 6 and add up to a negative 5. So the numbers have to be negative. If you did negative 6 and 1, yes, that adds up to a negative 5, but it doesn't multiply to a positive 6. So now we set each factor in the denominator equal to 0. So x cannot equal 3, and x cannot equal 2. So there's my restrictions. So now we check to see, can I cancel anything to simplify this? Well, the x minus 2's could have been canceled, which means if we're talking about graphing, the x minus 2 would be an asymptote. And then the x equals 3 would be your your x equals 2 would be the whole because it cancels. X equals 3 would be your vertical asymptote. So now x plus 4 and x plus 3 can't cancel because they're not the same. So the simplified answer is x plus 4 over x minus 3 with restrictions of 3 and 2. So along with multiplying rational expressions, we can also simplify rational expressions, we can also multiply them. Steps are going to be pretty similar. We're going to factor the numerator and denominator. We're then going to set each factor of, remember, the denominator equal to 0 and solve for x. And again, because we are simplifying or multiplying, we're not graphing these. These are stated as restrictions. We're again going to cancel between top and bottom if possible. Now with these, because we have two fractions, you can either cancel with the top of the first fraction and the bottom of either fraction, or the top of the second fraction with either fraction as well. And then we rewrite it as one fraction by combining the numerators and denominators, by putting them together. So with these, what makes them harder is you have more to factor, because you have 4 possible things that you have to factor. So let's start with our first one. X squared plus x minus 6. So we're looking for factors of 1 times negative 6 that add up to 1. Since the 1's positive, the 3 is going to have to be bigger, or positive, and the negative 2, because 3 times negative 2 is negative 6, and 3 plus negative 2 is 1. So my numerator becomes x plus 3 and x minus 2. Going to its denominator, x minus 5 can't be factored, so I'm just going to rewrite it. Now I move on to the second fraction, x squared minus 25. Hopefully you recognize the 25 as a square. It's also a minus sign, so this becomes x plus 5 and x minus 5, because the square root of 25 is 5. And then we factor x squared plus 4x plus 3. Well, 1 times 3 is 3, needed to add up to 4. So my factors would be 1 times 3. So I have x plus 1 and x plus 3. So now in my denominators, all of them is where I find my restrictions. It doesn't matter how many parentheses in the bottom, you have to find the restrictions for each. So I have x minus 5 equals 0, x plus 1 equals 0, and x plus 3 equals 0. So this means x cannot equal a positive 5, x cannot equal a negative 1, and x cannot equal a negative 3. So there's my restrictions. And now we go back to the fractions and look for canceling. And remember, as long as it's on one of the tops and one of the bottoms, it's allowed to be canceled out. So I look and I say, okay, first thing I run into is an x plus 3. Do I see another x plus 3 on a bottom? I do, so that means they're going to cancel. Then I have an x minus 2. Are there any other x minus 2's on the bottom? Nope, so that one stays. X plus 5, nope, none of those. X minus 5, yep, there's one, so those cancel. So now my simplified answer is simply to put the pieces together. So on top, I have an x minus 2 and an x plus 5. And the denominator, the only thing that didn't cancel was x plus 1. So here is my answer along with my restrictions. Now keep in mind here that you could FOIL the numerator, but because we're trying to simplify it, we want it as broken apart as possible. So we're just going to leave it in its parentheses form. We have a one for you to try. So go ahead and do that. Check with each other as you're going through it and getting your answer, and then unpause this when you're ready to see how you did. Now, the one thing you might not have caught when you're going over this is this first one. Can you factor 2x minus 8? And the answer to that is yes. They have a GCF of 2. So 2x minus 8 turns into 2 times the parenthesis x minus 4. X squared minus 16, hopefully you got x plus 4 and x minus 4. Second numerator, x squared plus 5x plus 4 is x plus 4 and x plus 1. And the denominator for the second fraction should have been x plus 4 and x plus 4. So now, the only restrictions come from any of the denominators. So I have an x plus 4 equals 0, an x minus 4 equals 0, and then I run into x plus 4 again. Well, I already have it written, so I don't need to write it more than once. So my restrictions are a negative 4 and a positive 4. Now we go through and we cancel. So first I have a 2. There's nothing I could divide a 2 by down here because there's nothing on the outside of those parentheses. Then I have an x minus 4. Well, there's another x minus 4. So those are gone. Then I run into an x plus 4 here. Now there's 1 on top and 3 on the bottom. But you can only cancel if it's the exact same on top and bottom. So since I only have 1 on top, I can only cancel 1 on the bottom. Then I run into x plus 1. There's no x plus 1's down here, so that's going to stay put. So on top, I'm going to put together the 2 and the x plus 1. And on the bottom, I've got 2 x plus 4's. So I could either write it with both of them out, or if you see this answer, hopefully you realize that it's the same. Since I'm multiplying something by itself, I can also write it as x plus 4 squared.